Hi Dale, Preston Mooney here with my video presentation for our second assessment in Intro OCHS Health and Safety. I trust it will provide you with an understanding of the daily workings in my chosen workplace and some of the common hazards encountered whilst giving you an insight into the heavy equipment repair industry. So first of all, I'm going to give you a quick explanation of some key terms that will be used. Firstly, what is a risk? A risk can be defined as the possibility of illness, injury or death that occurs due to exposure to a hazard. So what is a hazard? A hazard is any situation or thing that has the potential to harm a person, i.e. a pot of boiling water on a stove that a child can reach and potentially pull it onto themselves. So to counter this, a risk management process has been put together to try and eliminate or reduce hazards in the workplace. Part of this process involves attributing a risk score to each hazard that then allows all the hazards to be prioritised according to their individual scores. This is done via a risk matrix. I'll show you this risk matrix in the next clip and hope that you enjoy the presentation. Thanks. Okay, so here's the table that I was talking about earlier that assists in our risk management process. It provides a likelihood rating, defined as a chance of this hazard causing harm to somebody, and consequence, the outcome expected if the hazard is encountered. All you do to use it is choose the chance of the hazard occurring down the left-hand side and the severity of the outcome if the hazard occurs across the top and join them up to give you the score. This is the second part of the table, which shows how the risk is rated from low through moderate and high to acute and what actions are required for these. This will be very useful in the three hazards that I am going to showcase in this presentation. So the context of my workplace could probably best be described as a heavy equipment repairs workshop, undertaking a wide variety of work, including but not limited to repair, replacing and manufacturing of components, disassembly and reassembly of heavy equipment from smaller sized equipment to larger mining equipment, i.e. trucks and dozers, that when fully built can actually weigh in excess of 500 tonnes. As you can imagine, when you work on something this big, everything is bigger, including the hazards. So the three hazards that I've chosen today, I come across fairly regularly. These hazards make up a typical day for me and can be encountered multiple times. It's how we deal with these through constant vigilance and attention to safety that ensures that we go home as we come to work at the end of the day. So my first hazard I've chosen is an oil spill caused by an untidy work area that could result in a slip or trip. The oil spill is the primary hazard I've focused on in these first clips, but as can be seen, there are a number of other hazards present, including air and electrical lines presenting trip hazards, and components not yet placed out of the way. The average human male stands somewhere between 1.6 and 1.8 metres tall. If they are to fall down from this height, it is possible to cause serious injury, but unlikely to cause death. In the following photos, you can see the work area heavily cluttered, with high potential for serious injury. Now, by looking at these photos and referring to our risk matrix, the likelihood of this happening I am putting at likely will probably occur. I've come to this decision as, due to the painted floors combined with excessive oil, fuel and water spills and the high traffic flow in the area, it is likely that someone will encounter a slip or trip of some degree. So, for the second part of the assessment, the consequence. I have rated this a moderate. Looking at the severity listings under the moderate heading, medical treatment required, I believe is the most appropriate rating, as if someone is to slip or trip, injuries may include strains, sprains, bruising, lacerations or possible fractures. Righto, my second hazard involves a suspended load. Note, in the photos there is no barricading, indicating the designated travel path and fall zone. This can allow people to enter under the suspended load, potentially exposing themselves to being crushed. This photo shows the cabin of the machine being removed for overhaul. Note, in the next photo, it shows the weight of the cabin at 2.18 tonnes. This in itself represents a significant hazard, due primarily to the weight and complex nature of attaching the crane. So, referring to our matrix, I'm going to rate this as unlikely. Factors influencing this include, after conversing with the crane operator, they indicated the following: competent and authorised for type of crane, trained and experienced in this type of work, inspection of lifting equipment, lifting points and crane had been undertaken. A Take 5 and job hazard analysis had been conducted before the lift was undertaken. Relevant personnel and shift bosses had been informed of the lift. Work ceased on the job until the lift was completed. The lift was conducted whilst minimal personnel were present and other personnel were utilised as observers and lookouts whilst the lift was conducted. Now taking a look at the consequence. I am giving this a catastrophic rating, primarily due to the weight involved and the lack of physical, unending barricading. No matter how many precautions are taken, without this, if the person walks underneath and the load falls, it's unlikely they will survive. Lastly is a potential electrical shock caused by an electrical lead coming in contact with water spilled on the ground. Looking at our matrix, the likelihood of this happening is a rare. I've come to this conclusion after speaking to an electrician and also conducting some research into how electricity works. For the actual water to become electrified, it requires electricity to come in contact and pass through it, either back to another pin in the electrical socket or through an object that is earthed, i.e. a bench or human being. Another factor is a typical electrical socket these days measures from point of contact on the surface to the outer face of the socket, approximately 15 to 17 millimeters. The water would have to be deep enough to cover this to make contact with the electrified pin. Domestic 240 volt electricity has very little ability to jump, so the water would have to be practically touching before the electricity will arc across the gap. Again, due to the timing in the day and constant traffic flow, I'm going to rate this consequence a catastrophic. It only requires a very low current measured in milliamperes to pass through the body, causing irregular heart rhythms and more than likely cause death. That showcases my three hazards. To finish now, I'm going to give priority to the three hazards. Firstly, the slip trip hazard is the one I'm going to give the highest priority. This is not because of its consequence, but because of the likelihood of it happening, which I know it actually did. Secondly is the electrical hazard, as the leak for the water actually was causing it to grow and contributing to the chance of electrification. And lastly is the suspended load. I've given this the last priority due to the precautions and procedures that were undertaken before and during the lift. This concludes my video submission for Intro OCHS Health and Safety. Thank you for your patience and attention.